This is logical stuff. So with the radius of convergence, we do what we did before. Here's a regular power series. And if we took the limit, n approaches infinity of x to the n plus 1 over x to the n, didn't you find that to be what? X, right? And x has to be less than 1. So we call the distance from 0 here to here or here to here is called the radius, equal to 1. But my interval is going to be, and this is my little technique, nobody else has to do it this way, but students like to do it, is put little dashed marks like that between -1 and 1, because we don't know. We don't know yet. We know that the interval is from -1 to 1, but we don't know if 1 is included or if a -1 is included. Are good. Yeah, they're going to be good. But we're just going to check. I call this checking endpoints. And so to do that, all you have to do, and I don't like the space that I have here, I'm just going to move this if it'll let me. Ooh. Is all this going to move? Maybe. There we go. Good. All right. So we're going to check x equal to -1, and we're going to check x equal to 1. All right. So we start with the original series, which was the sum. N goes from 0 to infinity of x to the n. Now, if x is -1, we have the sum as n equals 0 to infinity of -1 to the n. So this is going to be 1, then it's going to be -1 to the 1, -1, plus 1, -1, plus 1. Do you think that'll converge? Tricky question. It doesn't. Because it'll go to 1, and then it'll be negative. So it'll go to... You add the first one, you get 1. Then you get 0. Then you add 1, you get 1. Then you get 0. Then you add 1, you get 1. It's going to alternate 0, 1. Is that 0, 1, 0, 1 sum, is that one value? No. So it's not gratifying, but that's a diverge. Because it's 0, then 1, then 0, then 1. Okay? And so we would put a parenthesis around this one, not including. Then we check x equal to 1. The sum as n goes from 0 to infinity of 1 to the n. Well, this is just going to be 1 to the 0 is 1, 1 to the 1, 1, 1, and so on. Well, that's obviously going to do what? Diverge. So that's a parenthesis as well. So this is my interval of convergence. And you can use kind of by sight if you want to. By looking at these, you can kind of tell. And when you get your intervals, it's going to be these critical 1 and -1s are going to come out. There you go. That's interval convergence. Let's try a second one. This one is going to make a little bit more sense, I think, because you can get something other than 1 and -1. You're going to take the limit as n approaches infinity of x to the n plus 1 over 3 to the n plus 1. Invert and multiply 3 to the n over x to the n. You can see how this limit, n approaches infinity, is going to be x to the n times x to the 1 times 3 to the n over 3 to the n times 3 times x to the n, which is x over 3. So using this ratio test, what does x over 3 have to be less than? Same as before, less than what? 1. So we can multiply by 3 and get the absolute value of x is less than 3. What's my radius of convergence? 3. Radius of convergence. And that's just r equal to 3. That means for this one, between negative 3 and 3 looks like what my interval is. Then you check x equal negative 3, and you check x equal to 3. So let's do negative 3 first. So you have the sum as n goes from 0 to infinity of x to the n over 3 to the n, which is going to be, in this case, sum as n goes from 0 to infinity of negative 3 to the n over 3 to the n, which turns out to be negative 1 to the n times 3 to the n over 3 to the n. What happens there? Those 3 to the n's cancel. Did I do that too fast? Is that okay? Can you see that? So I did x is negative 3. So I get negative 3 to the n, which is negative 1 to the n times 3 to the n. The 3 to the n's cancel, and I get the sum, n goes from 0 to infinity, of negative 1 to the n, which is just going to be 1 minus 1 plus 1 minus 1. And do you agree that this is going to diverge? Because it's 0, then it's 1. 0, then it's 1. It diverges. So we'll have a parenthesis on this one. You try this next one. Sum as n goes from 0 to infinity, put x equal to 3 this time. 3 to the, that's easy. What's it just going to be? 1 plus 1 plus 1. That's going to diverge too. So you're probably asking, do they always diverge? No, they do not. Not always, but they did for these two examples. Yeah. Yep, and we'll see those. None of these examples had that, but you'll see those in some of the problems. So for homework, can do some of those. This was one I think I assigned yesterday. We're going to do number 2 together as a group, and then we'll see how that goes.